going to start by flipping it up. So the left-hand side has nothing in the opposite region, so I'm just going to copy that down. The right-hand side has some stuff in the opposite region, so when we flip it up, it changes to the opposite. The opposite of a negative, of course, is a positive. So when these x's get flipped up, they're becoming positive. And so the way I'm recording that is the 7x was just sitting there. This minus 2x got flipped up and became positive 2x. And then these 7 1s, when they get moved up, they were positive. They all become negative, right? And so opposite. Negatives become positives, positives become negatives. That's the key first step. I'm changing both of these. They were both in the opposite region. Okay. Now I can combine things if I can. So on the right-hand side, I look and I say, oh, I've got a bunch of positive x's. I could count them over on the tiles. I can just add them up here. I see I've got 9x minus 7, nothing else to combine. Okay. Now I'm going to move all the x's to one side, right? All the x's to one side. And so you sort of have a choice here. Usually, if there are negatives and positives, I usually move them all to the side where the positives are. So I'm going to take these 4 x's, I'm going to move them to the right. And when I move them, just like moving from top to bottom, when you move them from left to right, they flip. And so these 4 negative x's all become positive x's. So I just added 4 x's to both sides. Why did I do that? Well, because it got rid of all the x's over here. All that's left over here is just the 6 little ones now. On the right side, I could go through and count all these. I can also add them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That checks out because 9 plus 4 is 13. So I've got 13 x's. So that's in good shape. So now I've got these 13 x's all messed up over here. I need to get the stuff that is not x over to the other side. And so let's get this out of the way. This is still positive. So I'm going to take these 7 negative ones. I'm going to move them over to this side. And when I move them, I flip them. So they were negative. They're all becoming positive, right? And so the way I record that is I'm adding 7 little ones to both sides. I've got 13 x's here. I've got 13 little ones on this side. And now what I have to do, and it's a little pain to do this on the tiles, but we can see it, we can sort of visualize what would happen. I have to figure out what each x is, and so I sort of have to divide up into groups. And so on the right-hand side, I have to divide up into my 13 groups, right, because I've got 13 x's. So I'm dividing the right-hand side into 13 groups. And so on the left-hand side, I need to know how big is each group? Well, there are 13 little squares, so it's going to work just the same way, right? So each one little tile is sort of paired up with one of those x's across on the other side. And because they pair up perfectly, I know that each x is one tile. And the way I show that algebraically, I ran out of room here, is I'm dividing both sides into 13 pieces. And so this is telling me that x must be each equal to one little square. Right? And so each x is matching up with one square, and I have solved the equation.